Hello everyone, welcome to Sunrise classes. Yesterday we discussed about the addressing mode, what is the addressing mode and what is the use of addressing mode. And we found that there are many addressing modes that is used in CISC computer architectures. Now today we are going to discuss each addressing modes in details with an examples. So it will help you to understand and it will help you to solve the MCQs. Now let's talk about, yesterday we discussed that there are two type of addressing mode basically. One is sequential control flow addressing mode that is focused on data, and the another one is the transfer of control flow that is focused on the instruction. It is basically related to the segments, intra segment and inter segment communications. In sequential flow addressing mode, there are two type of addressing mode. One is register addressing mode, one is the memory addressing modes. Now we are going to discuss each of the addressing modes in details. Register based addressing mode, there is two addressing modes. One is the register mode and one is the register indirect mode. So what is happening, we know that the purpose of addressing modes to find out the data, find out the operand. So basically what is happening, we have a set of opcode and operand. This is opcode and this is operand. So from operand we have to find out the data, and where is the data? That is the effective address. So effective address is the address where data resides. So from operand, using the addressing mode, we will find out the address, effective address, and from effective address we will find out the data. This is the purpose of addressing mode. Now let's talk about the architecture of computer. We know this is the instructions. From here what will be happen in the normal, there will be some set of register is there. So let's talk about the 16 registers. Okay, so this is the 16 register. So for 16 registers it will be R0 to R15. So how many bits we need to represent? Only 4 bits. 4 bits is enough to uniquely identify which registers we need to work. Similarly, let's talk about the RAM. Definitely RAM will be the bigger than the register. So let's talk about the RAM. For example, this RAM is 1 MB. So how many bits is required to address 1 MB RAM? So we need 2 to the power 20 equal to 1 MB. So we need 20 bits to uniquely identify each address block. So in the register mode, actually we are not going to the RAM. It's only in the register. So direct register mode, what is happening? We will give the instructions like you see the example here, move AX to CX. We know that this instruction is working in this direction. So what it means, AX equal to CX. So we have to assign the value from the CX to AX. What is the CX? CX is a simple register. Now we have to find out the content of the register, and that is the data. So here effective address will be our register. So here effective address is our CX. So simply from CX, whatever the value is there, we have to just copy into the AX. So this is the register mode. This is the direct register mode. So from instructions, it will be register. Name of the register will be there. From there, we will find the data. That is also from the register. And we have to perform the operations on that. So this is the register direct mode. let's talk about the registered indirect mode. This is very important. Why? Because many of the memory based addressing mode is also based on the registered indirect mode. Okay, so what is happening here? From the instruction, from the operand will give you the name of the register. Okay, so in the instructions, registered name is there. From that register we will find out the effective address. That will be the effective address actually. And the from effective address we will go to the memory and find out the data. So what is means, if this is the register and this is the memory, then from here if I will say R1, so from here there will be some data. But what is this data? This is the effective address. It will tell you from which locations we have to take the data, and this is the data, and this is the effective address. So effective address, where it will be? In the register. And where is the data? Data is in memory. So register will contain the address of memory. Okay, this is good. Now what is the benefit of doing this one? So the benefit is here. For example, we already discussed that for 1 MB RAM we need 20 bits. Okay, and for this registers we need only 4 bits, because there is a 16 registers. So 2 to the power 4 equal to 16. Okay, now in this, if you give the name of the register, so how many bits we need? 4 bits. From 4 bits we know that which register, and from here we can go to the address and we will find the data. So it will reduce the size of instruction. So instruction size will be, if this is the operand, this part is operand, then it will be, if we are giving only one addresses, then it will be only 4 bits. If we are giving 2, then 4 plus 4, 2 operand will be there, then the 4 plus 4, 8 bits, if both are the registers. But using this one, what we are doing, we are going into the RAM and we are finding the exact data. So it will reduce the instruction length. This is the use of registered indirect mode. This is very important because in next one, when we are discussing the memory based addressing mode, we will use the same concepts for the base registers, for the index one, for the auto increment and auto decrement addressing modes. All these things, same pattern will be used. In the index mode, there is a specific instruction will be there, that is SI. Okay, let's talk about the example. You see here, example is add R1 comma R2. So important thing, in the indirect mode, either we are using this symbol or we are using at the rate. So both are important. If you see, this is in the instructions, so you can easily identify that this is the indirect mode. If it's pointing to the register, then the indirect register mode. If it's pointing to the memory, then that indirect memory mode. I will discuss that one. So you see here what is happening. Add R1 comma R2. So what it is doing, it will add R1 equal to R1 plus memory of R2. So what it means, it will go to the R2 registers and that will be the effective memory. From there it will go to the memory block and then they will find out the data. So this is the meaning of add R1 comma bracket R2. Similarly, move R1 at the rate R2. It means that we are copying from R2 to R1, but R2 is, we will go to the register R2. From there, we will find the effective address, and that address we will go to the memory, and from memory we will find out the data, and that data we have to move to the R1. So this is the register indirect mode. I hope it is clear. If you have any questions, please put into the comment box. And if you like this video and you think that it is helpful, please subscribe. Thank you.